I want to let you guys know this year, you've already done stuff like this. And so I just want to remind you what this is in a very elementary way, and then we'll go to a slightly less elementary. There we go. You go through your checklist and you would say, is it ln? So does it follow the u prime over u pattern?
No.
Not at all. The derivative at the bottom is 2x minus 5, and that's not anywhere near the top, so it's definitely not natural log. I'm going to erase my little step-by-step thinking process here just a second. So feel free to write what you want, but I'm going to erase this in a second. Is it flip up? Well, if you tried flip up, it would be the antiderivative of x squared minus 5x plus 6 all to the negative 1. What's so bad about that? You'll end up with 0 on the denominator. You might be thinking that it's ln, but then you just eliminated ln before, right? So that's out. Okay. So then you might think, is it arcsine or arctangent? And this is where it gets a little bit more interesting, right? Which of those two is it definitely not? It's definitely not arcsine because there's no square root, right? But didn't we do some questions like this that involved arctan? Kind of looked like this, right? I mean, that doesn't look exactly like arctan, but what did we do back in chapter 5 to something like this? We completed a square. So we might need to investigate this. So let's do this. Feel free, if you want to write this down, just realize we're going to do something different than this. I'll erase all my stuff, and I'll get to the real thing here in a second. But I want to show you why it's not arctan. You might say, okay, well, let's go ahead and complete the square on x squared minus 5x plus 6. And it's a little ugly, but ugliness does not prevent us from doing complete the square, right? So maybe what we would do is say this is really x squared minus 5x, group those first two, get the plus 6 out there. The whole split the b and square it, a little tough. What do you get, Jack? That's right. So we go plus 25 fourths. And then what do I need to do to the outside to balance that out? I subtract 25 fourths. And so you're thinking, hey, I think this is arctan, right? Because then this would factor as x minus 5 over 2 squared. And then what is 6 minus 25 fourths? Minus 1/4. And we think, hey, this must be arctan, except it's got to be plus. It's got to be plus, right? Remember, arctan is the form is u prime a over a squared plus, not minus, u squared. So while you'd get to this point, if you were really paying attention, you'd be like, whoa, is this a weird arctan with a minus? Remember with integrals, even the littlest tiny details, if they don't fit, means that it's probably some totally different form, even if it's a little detail. Dylan.
Could you do it where it's imaginary numbers and have an arctan?
Could you do it where it's imaginary numbers and like an arctan, right? So it would be 1/2 I quantity squared or something like that.
Yes.
So we're going to only deal with real numbers here, and there is a whole different branch of calculus that deals with complex numbers. So perhaps you're onto something there, but we're just going to stick with real numbers only. That is a thing. It's a great question. Okay, so do you see at least with real numbers how this doesn't quite fit arctan? It's close, but it just doesn't fit. Close is not good enough. Okay, so here is kind of the final piece to the puzzle. Let's think about, this is your framework for thinking. I'm trying to crawl in your ear and say, here's how you should think. Try ln. Was it ln? Nope. Flip up. I'm not going to poke around too far. I'm just going to tell you some stuff, all right? Is it flip up? No. Is it arcsine? Pretty clear no. Is it arctangent? Barely no, right? So the only other alternative, and this will be our final alternative for this year, is you've got to do partial fraction decomposition. Because if it's not that, it's either a bad question or you made a little mistake.
Wait, this is the last possible?
This is the last tool in the toolbox for antiderivatives as far as different forms and stuff. You can keep going, but this is the last one we're going to look at.
Is it possible for something to fit under both arctan and partial fraction decomposition?
I don't think so.
Okay.
I think just depending on what that second number is, if it's plus or minus, is going to make all the difference. Yeah. Okay, so let me get rid of all that stuff because that's all the stuff that it isn't. Here's what we actually do. Do you guys see why that's valuable? I'm trying to give you context. Why would you pick the thing you're going to pick other than the fact that it's in section 8.5 in your book? Anyway, let's see. I'll just get rid of all this in one shot. Bye-bye. And here we go. So you've determined that the only way to do this is partial fractions. Here's how this goes. Step 1, factor the denominator. If the denominator is not factorable, that means it's probably one of those other ones and you made a little mistake, right? So this denominator factors as 1 over x minus 6. Nope. X minus 2, x minus 3.
Yeah.
Okay. So we get that factored. You can do this part off to the side if you want, or you can do it right smack in the middle of your question. For whatever reason, I tend to do this off to the side. Here's how you set this up. 1 over x minus 2 times x minus 3 equals a over x minus 2 plus b over x minus 3. We're basically saying I have no earthly idea how to break these up, but I do know that if they do break up, there's going to be some number a and some number b that work out. Now, like I said, these are non-repeated linear factors within this partial fraction decomposition, and so that ensures that it's going to be simple like this. It's not, remember how you have to do like ax squared plus b for one of the numerators sometimes and all that stuff? We're not going to go there. We're going to keep it really, really simple with these, okay? So you understand what we're doing here? We're saying we have a fraction and we want to know how to break it up into two fractions. If we can do that, it's going to be a pretty easy finish. Okay, so the way we continue on here, I will not often show this step, but we would actually like to eliminate our denominators. The way that we do that is to multiply by the least common multiple of all the denominators. So I'm going to multiply everything through by x minus 2 times x minus 3. And that's going to eliminate all my denominators. It's going to move some stuff around the way we want it. So when I distribute over to here, wouldn't it be fair to say that the x minus 2 would cancel with the x minus 2, and the x minus 3 would cancel with the x minus 3, leaving us with what? Nope. For the first term on the left there, it would just be a 1. Like everything would cancel, leaving you with just a 1, right?
Well, I have mine in a different order. So
That's fine.
First,
Please excuse me if I'm going too fast, let me know. Then here, what would cancel out when I multiplied times that term? The x minus 2s would cancel, leaving us with a times x minus 3. And then how about when I multiply to this term here? That's right. The x minus 3s would cancel out, leaving us with this. Now, kind of like your good examples that you saw up here from your classmates, I'm leaving out a couple of algebraic steps. So if I have confused you by that, let me know. Do I need to fill in a couple of blanks there? I'm happy to do it. Okay. So then what we need to do here, we need to figure out what the a and the b are. And the way that we're going to figure out what the a and the b are, we have to do it one at a time. I've got 3 variables up there, and I've got x's, and I've got a's, and I've got b's. I essentially want one of my 2 terms on the right side to go away. And so here would be one way to do this. I'm going to say if x equals 3. Right, so within any equation, aren't you allowed to plug a number in for a variable as long as you put it in for all of those variables, all of that particular variable? So I'm just going to be evaluating this when x equals 3. So when x equals 3, I get 1 equals a times what? 0. I did that on purpose, right? I wanted one of the terms to go away. A times 0 plus, and of course 3 minus 2 is 1, so it would be 1b. Therefore, 1 equals b, right? Because a times 0 is just 0. Okay, so if I found my b, which is good. If I wanted to find my a, I need to do a different evaluation. I need to say if x equals 2. That'll get it done. So I'm going to say if x equals 2, then I get 1 equals a times negative 1 plus b times 0. So we made the other term go away. So this is kind of your standard partial fraction method for these most simple types. Jaden, you okay?
Yeah. Just wondering why you're not doing RF in the matrix.
Because you got to be able to do these without a calculator. Unless you think you can construct an RREF real fast, I would suggest doing it this way. Fair question, though. Okay, so then that means that a equals negative 1. So then what I can do is I can use this framework, and I can say that this integrand is the exact same thing as a over x minus 2 plus b over x minus 3, and I just figured out my a and my b. Make sense? So I can replace this with the integral of negative 1 over x minus 2 plus positive 1 over x minus 3 dx. So it's at this stage, I would definitely recommend breaking these two terms up into two separate integrals. It's not going to be a real big deal here, but in other cases, based on what the denominator is, it's going to be a big deal. Question?
So the whole thing about the numerators are going to be easy, so it's all just going to be numbers. It's not going to be like x plus 5 or x minus 2 or something. It's always going to be like just like one number.
Typically, it should just be a constant.
Okay.
Yeah. Yeah, because you have linear non-repeated. I think you're going to end up with that pattern. I think. Yeah, I think so. Okay, so like I said, I would suggest that we go two separate integrals. Let me just start over with that. That was pretty terrible.
Looks like a natural log.
It looks an awful lot like a natural log. I agree. Okay, in fact, both of them are, right? So the first one ends up being negative natural log of absolute value x minus 2 plus natural log of x minus 3 plus c. There is an alternative form of this answer. Anybody want to take a shot? Josiah?
Natural log of x minus 3 over x minus 2 plus c.
Yep, looks good. So use that log property where you can condense down. For subtracting logs, you get the log of a quotient. So it's definitely right. And I would be comfortable with either one of those forms. Would not just be stuck on one or the other. Okay, so you guys were less apprehensive than some of my other classes. Like some of my other classes, I've said partial fractions, and people were like, no, I didn't sign up for this, and they're like super upset, and yeah, they just want to leave and run away. But you guys didn't react quite that way, so that's good. Did you see how it's the easiest version? You're numb. Yeah, I can't even react. All right. So I hope you feel like it's okay. It's not too bad. If you guys would take a look at example 2, see if you could do number 2 on your own, okay? Ready, go.
You had to like do huge square REX, I would just compare the tiers and test.
So if we get to the end and my answer looks different from yours, and you're like, well, I think I got this right, it could be that we're both right. So don't stress. We talk about that if we need to. So did you guys all, and I don't know if you did this or not, but I think it's worth, I'm not going to go through this again, I really think it's worth reminding yourself why this is not ln, why it's not flip up, why it's not arcsine, why it's not arctangent, why it's not long division for that matter. I really think that that's worth it. But we should then eventually arrive at this partial fraction decomposition, which tells us that we need to factor the denominator first. And it's that difference of squares we talked about a second ago. So it would be 1 over 2x minus 1 times 2x plus 1 dx for our integrand right there. And then, like I said, I usually go off to the side, and I will rewrite as 1 over that 2x minus 1 times 2x plus 1. I'm going to set that equal to a over 2x minus 1 plus b over 2x plus 1. And this would be the first point where we might have some like totally inconsequential disagreement. If you put your a over 2x plus 1, whereas I put my a over 2x minus 1, that means some of our little details in between are going to look different, but in the end it should be the same. Okay? So then if I multiply through to get rid of my denominators, I end up with 1 equals a times 2x plus 1 plus b times 2x minus 1. Once I clear out those fractions. And then to be able to solve for a and b, I basically have to plug in either a 1/2 or a negative 1/2. So I'm going to put if x equals 1/2, then I get 1 equals a times 2, right? So therefore, a would equal 1/2. Does that make sense? And then if x equals negative 1/2, then I arrive at 1 equals a times negative 2. Therefore, or sorry, b times negative 2. Therefore, b equals negative 1/2. Guys look like you're doing okay? All right, so they come back over here, and I'm going to rewrite this now as I think maybe I'll write it like this, to be honest. I'll go 1/2 integral of 1 over 2x minus 1 dx minus 1/2 integral of 1 over 2x plus 1. I'm going to split this thing up and get the constant multiples out right away. You could put them up there in the numerator, but I'm just going to pull them out immediately. Okay, so this is where this one gets a little more interesting, right? Because you look at both of those integrands, and they're both natural logs, right? Except Timmy messed up by what factor? Depends on how you present this, right? If I leave the 1/2 in there and I make it 1 over 4x minus 2, he messed up by a factor of 4. But the way that I have it written, didn't he mess up by just a factor of 2?
Yeah, so he's not happy.
So what if I did this? What if I just said times 2 times 1/2 times 2 times 1/2? Same thing, right? Okay, so let's see how this plays out. So this would give me 1/4 times natural log of 2x minus 1 minus 1/4 natural log of 2x plus 1 plus c. So of course I could condense this down and get, do the division thing. That would be fine. But did anybody get something different looking?
Yeah.
So tell me, instead of that, tell me the exact answer in 2 seconds. Ready, go.
Negative 1/4 ln of 4x plus 2 plus 1/4 for ln of 4x minus 2 plus 2.
Okay, so do you guys see how this and this are supposed to be the same term? But wait a minute, like I've got 2x plus 1, she has 4x plus 2. How is this supposed to work out? Check it out. Whoops, come on. There we go. Here's one way. What if we wrote this? I'll just focus on the first one. What if we rewrote this as ln of 2 times 2x plus 1? Does that make sense? And there's other stuff on the end. I'm just going to focus on the first one. Well, here's where we could use a log property. If you have the log of a product, you could expand it by what? Adding. Yeah. So this would really be negative 1/4 times natural log of 2 plus natural log of 2x plus 1 plus that other term, which we could be doing similar things with that other term. So then if you look at it, we really have this extra factor of negative 1/4 ln of 2, right? Like if you distributed the negative 1/4? It's part of the C. Make sense? Her C would be different from my C, at least in between. But if we got them all into the exact same form, the C's would end up being the same thing. Okay? So that would just be absorbed into the C. Our two answers are the same, just different forms. And that's okay. It's okay. Here, can I give you guys a little bit of advice from a testing perspective? Like in the AP test, they will always be pulling constant multiples out rather than multiplying them in. Make sense? So instead of distributing that 1/2 and making it 1 over 4x minus 2 and 1 over 4x plus 2, that whole routine, pull constants out and then do your antiderivatives versus multiplying them in and then doing an antiderivative.
So they would do it the way you did it first.
Correct.
And then if you combine them using log, doesn't it just become the same exact thing?
Mm-hmm. Yeah, because now you can see the way, as I rewrote this, when I get to here, well, now my first term agrees with my first term. Or I guess it's my first term agrees with her second term and vice versa. It's just that we have that extra factor of negative 1/4 ln of 2, and where does that go? It's just part of the C. Anybody else? Questions, concerns? Josiah?
When you break it down and you have the 1 over, like just in this problem, the 1 over 2x minus 1 times 2x plus 1 is equal to a over
Yep.
2x. Is it okay to just skip that step and go straight down by, what you did
Here?
is multiply across?
Is it okay to start here?
Yeah.
If you can do that mentally, sure.
Then
If you fumble it mentally, no, that's totally fine. To be perfectly honest with you, if you could If you could do all of this in your head perfectly and didn't show any work whatsoever, that's actually okay. It's a little uncomfortable because really you could do all that all by yourself in your head. Some people maybe could. And I'm okay with that. Yeah.
So if you do it right, will the solution always be an ln?
You're going to get a lot of ln's out of these partial fractions, right? And the reason is, that's a really good connection. The reason for that is because we have non-repeated linear factors. So you're always going to get some constant over a linear something or other. It's going to lead you to ln. So you'll get a bunch of variations on ln. All right, Liz.
So if you combine those two, could you combine them as like 1/4 of ln absolute value 2x minus 1 over 2x plus 1?
Plus c, yep.
Okay.
Yep, you sure could. And of course, that's because, of course, they're both ln's, and they both have 1/4.
Okay.
If one of them was 1/4 and the other one was like 1/5, can't do it.
Okay.
Okay. Hey, if you guys have not already looked at example number 3, please do that. Number 3 is a little different. I think if you go through your mental checklist, you'll find that you end up at partial fraction decomp again. It's pretty close to ln, but it's not.
That's fine. Do you multiply times?
That was your subpoint.
I can get with that.
Hey guys, take a minute. I just did this quietly up here because I feel like you guys are getting pretty good at this. Really all you need to do to see if we agree is to look at this. Were you able to do a partial fraction decomp where it's -3 over x plus 3 plus 5 over x plus 6? So all the details on the right might look a little different in between, right? Because we might have flip-flopped our A and our B, but in the end, we should have the exact same decomposition. So again, just encourage you to look at this and just look at what you have, look at what I have, ask questions. Anybody, we disagree? I saw a lot of these numbers like the -3 and the 5 kind of floating around, and so I think we're at least on the same wavelength here. Okay, so then the way this one would finish out is -3 times the natural log of absolute value of x plus 3 plus 5 natural log absolute value x plus 6 plus c. Is this one where I could condense by using the quotient rule for condensing logs? I mean, it's subtraction, right? So couldn't I just make it the log of a quotient? Why not? 5 and 3, right? So 5 and 3 are different. They need to be the same coefficient in order to do that. Outside. I knew what you were talking about. All right, so there's number 3. If you haven't already looked at number 4, please look at number 4, and we'll wrap up our class here in a few minutes. So look out for it. Make it the thing you look for.
Because I trust me about a 3. So do you know if you're gonna get it? I feel like you've done all the steps, right? Yeah. Like getting a nomination and all that.
Because I didn't really Are we talking math related or?
So guys, as we wrap up our class, I thought this would be a good place to get to. You guys listen up, please. Got about 2-3 minutes left. Do you guys get to this spot? We agree? It's 3 over 2x minus 3 plus 2 over x plus 2 is your partial fractions. Okay. So I think this final example here is a really nice example of when you really ought to split things up. Because you could really make a mistake here. You could look and you could say, oh, look, over here, didn't Timmy mess up the chain rule on that one? The numerator should be a 2. It's a 3. And so we maybe like get busy about multiplying top and bottom, or like multiplying the inside by something and the outside by something else. But unless you split these up, you're going to inadvertently multiply this second term by the same thing. And that would be a problem, right? And so I think we should split these up. So it look like this. 3 times the integral of 1 over 2x minus 3 dx plus 2 times the integral of 1 over x plus 2 dx. So do you see how the fix applies to the first term but not the second term? Because what I would do here is I would say, Timmy messed up. I need to go times 2 divided by 2. But do you see how that whole fix should not apply to the second term? Because the second term, the derivative of the bottom already is the top. So there's no fix. There's no u substitution fix needed. Question?
Will you lose a point? Like, will you not get a point for not separating the variables? Or can you just jump from step 1 to step 3?
So in other words, from here to an answer?
Yeah.
I'd be fine with that. Like, I think you can do this mentally. I really do. But be careful. Because it'd be easy to apply the divided by 2 to both terms instead of just the first term.
Okay, but you won't get like doctored.
Yeah.
Okay.
Okay, so you end up with this plus this plus c. Clearly cannot condense those for 2 different reasons, right? So, okay, guys, run to lunch. You have like a minute head start on people that got out on time.
Thank you.
Have a great day. Great weekend. See you on, I think, Monday, whenever that is.